This interactive simulation shows behavior for a system that obeys Raoult's law. So a binary system, ideal gas, ideal liquid, and what we're plotting, either pressure versus mole fractions in liquid and vapor, or temperature versus mole fractions. So let's look at what the display looks like. So here we're looking at the pressure mole fraction diagram, and the temperature then is fixed, and we can change the value of the temperature with the slider. We can also change the mole fraction by moving this dot around with a mouse. And on the right side, we're shown a bar graph that shows how many moles of liquid, how many moles of vapor. So we have a total 1 mole, and in this case, slightly more liquid than vapor, corresponding to the point at the dot. And then we're shown the mole fraction, so 0.64 is this value, and 0.27 is this value. So one thing to point out is we can control how this dot moves. So if we hold down the Shift key, then we'll move the dot at a constant pressure on the PXY diagram, or a constant temperature on the TXY diagram. If we hold down the Control key, then we'll move at a constant mole fraction, so move up or down, and that makes it a little easier to see how things change. So let's look at the interactive simulation. So here's the interactive simulation. We're looking at the pressure mole fraction diagram. So the blue line is the bubble point line, and the green line is the dew point line. And so I can change the temperature in both those lines, move, of course, and keeping the mole fraction the same. You can see as we change the temperature, we change the relative amounts of liquid and vapor. I've raised the temperatures, so I have more vapor, less liquid. I can move this dot anywhere in the diagram. If I hold down the Shift key and move the dot, then I can move at constant pressure on the PXY diagram. If I hold down the Control key, then I can move at constant mole fraction. So I can watch how a system fixed overall mole fraction changes, as in this case, I change the pressure at constant temperature. The option to also look at the temperature mole fraction diagram, where now I can change the pressure. So if I change the pressure, of course, then these points are the pure component boiling points, and they increase as the pressure increases. And likewise on this graph, I can move the dot at constant temperature by holding on the Shift key, or I can move it at constant mole fraction by holding down the Control key. So at constant temperature, and of course constant pressure, if I move the dot to the right, then what I'm doing is increasing the amount of vapor, decreasing the amount of liquid, but the mole fractions do not change if we hold the temperature constant. These type of diagrams are very valuable for understanding vapor-liquid equilibrium for mixtures.